Greetings, programs. This is Let's Code a Full 90, where we take the next hour and a half to dig into some source code and try to make our part of the world a little bit of a better place. I'm your host, Rob Menching, and today we're digging into the Wix toolset. All right, this is what we've been doing for the last, 19 weeks, I think. Well, 18 weeks. This is the 19th episode, so it's been 19 weeks. This has been fun. We are continuing our semantic versioning saga, as I've come to label it, just for fun. And we're going to continue to pick up the little bits and pieces that we have hanging around to finish this work off. So let's go ahead and look at what those are. Most of the high order bits, I think, were captured back in episode 15, and we've been slowly working our way through checking those off and then adding a few more work items last week. So this week, I think what we're going to try to tackle is number one up here, validate the versions in the upgrade table. I don't think that'll be too hard, but we do need to make sure that works, that we are validating versions correctly that are in the upgrade table. I'm just repeating myself at that point. I mentioned last week that we're going to skip this patch family, the use of patch families versions until I get into patching, to make sure I have full context, which I definitely do not have right now. So I will revisit that in the future. We'll probably just open an issue and before we close this one. But then this one is interesting. We need to evaluate the dependencies, custom actions, use of version numbers, and how we should go and what sort of restrictions we should keep on those. I think we're going to get to that one as well today. So we're going to look at the upgrade table. We're going to look at the dependency, custom actions a little bit. But before we do all of that, I wanted to jump down here and take a look at, decide what to do with this version fixture. And I made this offhand comment at the end of consider fixing it to make the failure cases negative tests. And I think that's probably what we'll start with. So we're going to start by trying to get the test passing, because this test is currently failing on my machine. We need to get that working, and then we'll jump into the upgrade table and the dependency custom action, and then we'll move our way into the dependency custom action to see how far we get in the next 90 minutes. That's what we're going to do. All right, so without further ado, let's go jump over to Visual Studio. This is where this is the tests that are failing, these red ones, this semantic version test, where we were messing around with this MSI, trying to create lots of different tests to see what the actual behavior was with the Windows installer when it had funky versions like this everywhere. And I think what we said was I want to turn these into negative tests to basically say, hey, let's run this, build these things, and then make sure that we are validating them. Because we have some decent error messages over here to go ahead and check. Invalid product version 257. Product versions must have a major less than 256, a minor less than 256, and a build number less than 65536. So I think we're going to go ahead and run with this test. And the question is it worth it to split it up into several tests or to keep it all as one? It's probably a good idea to make it separate tests. We just had this all as one just to see what would happen. So let's go ahead and fix this test. So this is not going to be success. So assert false. Yeah. Result dot. Oh, maybe I should just do execute. All right. Whoops. Assert equal. We expect the exit code. What number do we get? 242. Cheating over here. I think this is it. Failed with exit code 242. So hopefully that's green. Yep, okay, that's good. And then we want to validate the single error message that we should have here. So let's go ahead and do that. Var, I don't know if we need to do this. Result.messages.single. Yeah, that's great. Where the message is level equals error. Let's go ahead and take that off and push it up to the usings. There we go. Should be an error. And now we can do assert.equal. And I like this error message. So let's go ahead and grab, I think this will be the whole error message. With that. And m dot message dot, bummer. I don't have it formatted. All right, let's see. If we do toString, what do we get? Do we get the right answer? I think we don't get the error. We just get the invalid product version. Are we building? No. expected semicolon. Yes, semicolon at the end. There we go. And that failed because the message is, yeah, just the part without the error number, right? The 242, we check in the error message up there. And we will do that. Cool. I think that's the answer. Let's go ahead and do it that way since that tells us better. Okay, great. Now, what are we doing here? Here we're doing an experiment to build with a dot at the end. I don't think we really need to check that. But let's check this result 3. What does result 3 give us? This is building a bundle. And this is failing. Why is this failing here? The system cannot find the file test1.msi. Oh, because the MSIs are no longer building, so this bundle no longer builds. All right, so we need to update this version bundle.wxs to refer to an MSI that exists. Right, let's go ahead. Let's see. And we need to update. All right, we're going to copy this whole thing, paste it, and see how many more tests we want to kind of chop out of this thing. So the bottom parts of this goes. The bottom part of all that goes. And we want to say, cannot build MSI with invalid major version, because that's what that test is doing. Cool. Now here we want to build an MSI that passes. So why don't we go ahead and push the boundaries on all this 65535, right? This will now fail because it should be 2556. Oh, max is 255. All right. Product version must have a major less than 256. I actually would put 256. That's silly of me. Less than 256 and less than 65536. There we go. Okay, got the last one right. And now it's failing because there are no error messages, which is correct. Result dot assert success. There we go. Come on, type. All right, we're good with that one. This is not any different than that one, is it? No. It's building an MSI2 path. Okay, we're not using that now, are we? Nope. And we're not using that up there. Okay, great. Just cleaning up some of the things we had. All right, so we had modified this test to build 2 MSIs for us within 1. Don't need that. MSI2, although, does this bundle need 2? I guess we'll find out. We could look at the code or we could just see what happens. All right. Ah, there we go, result. And this failed because it failed to find the test MSI, the second test MSI. Let's go update the bundle because I don't think we need to build 2 MSIs just for this test. Version fixture, we want to go look at the version test data, look at the bundle. Yeah, we don't need to build 2 MSIs. I'll just make the test run longer for MSIs that have to be valid anyway. And that is not the MSI version number anymore. It is now 65535. MSI built. There is no second one, and then we should be able to extract the bundle out and everything is good. Okay. Can build bundle with MSI with max MSI version. All right. Okay. Oh, can build bundle with semantic version. All right, that's actually the bigger part of this test. There's that. Now, let's look at the results. What do we get out of here? The extract result. We need to look at that. So make sure that's correct. Extract result dot. Let's see, which one of these is the one that I want? BA data? No. Bundle extension data? No, I think I want the manifest. There we go. It's the manifest document. Is that an XML? Yes, XML document, not X document. That's fine. All right, we can work with that. I have to remember how to though. Let's see. Let's get the bundle version. Select single node. Okay. And is it XPath? Yeah, it's XPath. I don't even know where it's at though. Let's see. Bundle at version. I don't think that's right, but let's go ahead. Assert dot equal. And we want this number here. This is a crazy number, but that's okay. It's still a valid semantic version. Bundle version dot value. Okay. Now that's not going to work because that's gibberish. Let's see here. Let's pin this test. Bad habit when I don't do that. Bundle version is invalid token. Has an invalid token. All right, well, let's just look at this XML right now and see what we got. Debug, please. I'm not really worried about that breakpoint. Probably not worried about most of the breakpoints I'm going to hit. Nope. Update payload version. Nope. All right. So now we have the manifest document. Let's take a peek at it while it's here. Let's see, can we get it as an XML? Inner XML? No, I'll probably do. Oh yeah, no space. All right, burn manifest. Great, all right, so that's the top. Burn manifest, related bundles, variables. Oof. Let's see, can I bring this over to code and have it format it for me? XML, can you do that? Format document, please. But prettier. What? I don't know, let's try. Okay, that worked. There we go. All right, let's see. Where did our bundle version get put? Into the registration? Yeah, it makes sense. Yeah, there it is. So we want burn manifest registration version. And I bet namespaces are going to be a pain. I have to remember how to do that. Okay, so back to where we were. And this is definitely not where we want to be. Bundle registration at version. And you're still going to tell me, oh, nope, that's not the right answer. The answer is burn manifest. Burn manifest, right? Right. All right. So now I need to get the namespace correct. So I need to go see who else uses this in all these tests and see if I could find. That's mine. There's that's the bundle extractor, bundle result. Yeah, I wanted to see the people that were using this though. Yes, can you show me? Thank you. Yeah, I guess. All extract all containers, bundle fixture. That should work. I hope. Let's see. Nope. He's just making sure that it could extract. Container fixture. There we go. Let's see. Select manifest nodes. Okay, I see. And then we'll just do that. Okay, so we have a helper function and we can do that. Okie dokie. Let's see if that will work. I want this, but I want, all right, so it's burn : fine. Burn registration. That's select manifest nodes is on the result, not on the XML document, which makes sense. And that is not a value. Okay, so this is doing a cast. I should have an XML attribute. I think an attribute, doesn't it have a value? Wait, what? enumerable. Oh, oh, that's nodes. Okay, fine. My bad. My bad. Cast. Let's do single. And then the cast. Or we could cast and then the single. Oh, really? Not using a link here? Yes. Okay. This. Oh, is the next. Oh, fine. We'll do it the other way around then. And now this. Now does it have a value? Yes, now it has a value. Okay. Let's see if we get an something back yet. Nope. Still wrong. Has invalid tokens. Thought that was the syntax for finding an attribute. Burn. All right. Now we know it's select manifest nodes. Let's see all the places where this is used. Oh, square back. Gosh, it's been so long since I've done XPath. Oh, shoot. There it is. Square bracket. Yeah, okay, fine. Square bracket grab, but square bracket grabs the element that contains that attribute. I actually want the attribute. Yeah, that's searching for the ID that has that value. All these are grabbing elements. Nope, that's me. I found a match. All of these are looking for manifest nodes. Interesting. All right. I guess I'm the only one that has wanted maybe slash. It's not slash. Is it square bracket? Oh, it is slash. Okay. I want the children of registration, and then I want the attribute version. Gosh, I have not done enough XPath in a long time. All right. That's great. That's awesome. All right, cool. So now we have a semantic version bundle. We do not have a semantic version MSI because, well, as much as I want to find a way to make that work, can't quite bend the rules enough to do that. Okay, cool. So these tests are building now. That's progress. That's progress. We don't need the bundle fixture. We don't need the result. We don't need the container fixture. We don't need the bundle extractor. Don't know that. We will need bind database. All right. So I think on our list of to-dos, don't save that, just temp file. Our list of to-dos, we are checking this off in done in episode 19. Not sure if this is the best way to do it. All right, now we're gonna go tackle the upgrade table. All right, so I had to went and dug up the documentation on the MSI, and version min and version max. Well, version min and version max are the things that we're looking at here, text and text fields. And they said that the version min must be a valid product version as described for the product version. As described for the product version property. By the product version property? For the, okay. Oh, they're consistent for the product version property. As described for, Anyway, the product version property is the one that we've been talking about, 255, 255, and 65535. So we need to make sure that these version numbers are in range. So the place where that's going to be handled is create data from IR. Create Windows installer data from IR. Yeah, so this is the class that takes the data that the compiler and everything processes and then turns it into MSI specifics. And in here we should find handling for the upgrade symbol. Handling for the upgrade symbol. In here it turns it into an upgrade row. And we just have symbol version max and symbol version or min and max. And these are just strings, I hope. Yep, string and string. Great. So if, and I then need to go and find the place that checks the product version. Yeah, verify version. Yep, so if this, there we go. If the Windows Installer backend is valid MSI product version, needs to be a valid MSI product version. So You can grab these and bring that over here. I guess I can just take that if and that if. And we can now take our symbol and say that. Source line numbers of the symbol. So now we handled min version. I should have copied this. Uh-oh. Do we not have a backend helper? Backend helper. We do have backend helper. Window. Oh, it's just called backend helper. I guess that's fine because we're in the Windows Store at this point. Just backend helper. All right, cool. And then this. And version max is in range. Whoa, we're having a lot of things fail. Oh, it can also be null. Nullable. Yes, great. Let's see. If we have a symbol version, and it's not that. Otherwise, if we don't have the symbol version, then it's okay. All right, let's see here. Symbol, max. Okay, great. All right, now we have a bunch of tests think that they're failing, or at least they're trying to run. Or someone got stuck. All right, great. All of our tests are passing again. Oh, here. XPath is, haven't you, right? Tested? Yeah. XPath is always. I agree with both of you. Searching for a single attribute was new, looked new, and XPath is pretty much awful all the way around. I've gotten so used to dealing with Xdocument and its programmatic way of navigating that I've pushed all of the XPath knowledge to disk. All right. So that'll check the invalid product versions on those, and let's go double check the implementation of this. Backend helper is valid product version. Yeah, so then we try to parse it as a version, and if any of those, and we ignore the fourth. Okay, cool. So we try to parse as a 4-part version, and then we ignore the fourth part, which is what the Windows installer does, is ignores the fourth part if there is one, and we just have to make sure it's within that. All right, great. So that looks good. Let's go add a test that does not have a valid upgrade symbol. So we have, I see upgrade here, detect only. All right, great. Let's go look for things that use detect only.wxs. MSI query fixture. Yeah, okay. Populates install execute sequence. Interesting. And it uses the detect only to do that. Okay. I mean, that's fine. It's not quite what I want. And I don't want to bulk up this test any more than we already have. Been going to the switching to smaller classes instead of, like, we just started by dumping everything in these big classes, and they've just become unwieldy after a while, unless they really do need to share things, and so many of these are different. So I'm going to essentially grab this test, but I'm going to put it in a new test. We don't have any upgrade fixtures, so let's go ahead and create one. Ugh. Although we do pick up a lot of upgrade tests from other things, I think the negative was going to have to be in its own test. Please, yeah. Upgrade fixture. Boom. Okay. X unit, please. Yep. And test data, please. Yep. And I think we've been making ours all public. Thank you. System IO, please. Man, didn't realize there was many things I had to add. The core test package. Yep. All right. All right. Now we are going to do cert.equal. I don't know what the number is going to be. Result.exitcode. .exitcode. There we go. There we go. Okay. None of these things are going to be true because we're not going to get an MSI. Right now, of course, we are. So upgrade, invalid, min version. I guess we'll call it that. Okay, detect only. Invalid min version. I probably should put upgrade in there, the word somewhere. In upgrade invalid. I don't know. Oh, upgrade invalid min version. Component upgrade. That good is fine. Minimum. Ah, hey, it's already here for me. And that's all fine. Goo just to make the tests go together. And what are we going to do? We're going to do 257 again. Or no, let's do 1. We'll put 257 here just for good measure. Okay. And now we run that test. Pin that test. 242. Oh, of course, it's the same error code, Rob. It's the same error code as the last one we looked at. Right here. It's this. Let's grab that, but we're going to get a different we're going to get 1.257.0.0. There we go. And add database. Run. Boom! We have that failure. Awesome. And just to validate that it really was my change, let's change this to 8. Let the test run. It will fail because it says 258. Yeah, I like 257, 257, or actually 256. That's even closer. I don't know why I keep doing 257. 256 is out of range too. Boom. All right. That's pretty good. That's pretty good. Okay, let's go look at the compiler. That's upgrade code. I'd like to see the upgrade element. Upgrade, that's major upgrade. Upgrade element, parse upgrade element. Oh, right, upgrade version element, actually. Right, and get attribute version. Okay, this is perfect. And this goes down into all of our new code that we wrote with Wix version and all that kind of good stuff. All right, great. Great. That's good. Cool. I think we've run all the way through. And we now have version min and max checked. Okay. All right. All right. That is going well. So I'm going to grab this little message and say we did the same thing here. Cool. And we're a half hour in. How's that? That's great. All right. Break for a drink here. Ah, awesome. Cool. That means the next thing on our list to tackle is the dependency custom action. And this is going to be a bit more interesting. This is not code that I'm deeply familiar with. I don't think I wrote any of it. And so we're going to have to go kind of spelunking through the code. I have looked at the C++ code a little bit just to see how it was shaped and where to find it. You can see it up here in these tabs. That's all the code I think we'll need to run down the dependency custom action validation code. And so we're going to go do that next. After that, I think we'll just need to go back and make sure that we're in a good place. And then we'll be done. Because I'm going to open a bug for this patch family version and just solve patch family versioning when I do patching. So we're just going to pin that thing and put it away because I don't want to do any work in there guessing what it is without really digging into it. So yeah, I think this is the last thing we need to tackle for semantic versioning, except writing down maybe a note and then these error messages. I keep going back and forth about where to put this invalid 4-part version message because it's almost generic, but it's not. Anyway, not going to worry about that. We have that. I will just sit and stare at it one day and then decide what to do with it. It's not wrong in either place. That's the problem. All right. So, and then this note, I will probably open a bug or add a to-do in the web project to talk about this documentation, where we now read the version number from the string file version, string product/file version versus the numeric, I guess, product/file version. All right. Yes, okay. I keep rehashing this because it's like we're getting close to the end. What's the current high-level goal? Zach, yes, the high-level goal. The high-level goal is to support a more full range of version numbers throughout the Wix toolset. The big thing being that Burn has been updated to support version numbers that it might find out in the world. Because Burn can contain other installers, they may have other version numbers, semantics different from what the Wix toolset, from what the Windows installer has, or even from what Burn has. And we had an issue where Burn was failing to even read it and blowing up because it couldn't read the version number, if I remember correctly. So Sean already did the work in the engine to support more advanced version numbers. So what we're doing now here is updating the core tool set in all the different places to make sure that the version numbers can flow all the way through. We started this, and I should have written it down. Probably episode 14. One of these episodes back here, I'd have to go back and look. Episode 14 or 15 was a fun episode. It was 90 minutes of us exploring how far we could push the Windows installer in its semantic versioning, its use of semantic versioning, being one of the big versions that we want to support. Since that's very popular now, the ability to have a semantic version and be able to have Burn, understand it, and have the Wix toolset be able to process it is a big thing. Wix version is a superset of 4.4 and semantic versioning to allow us to represent things and then do math across those properly, 4.4 versioning and semantic versioning, and general logical comparisons for anything else that fits in that space. So that's what a Wix version is. We're teaching the core tool set, the build, how to handle all of this so it can end up inside MSI or a bundle. Well, an MSI of that. It seemed like me super. I thought it was fantastic, cool. The end result though is that we did not choose to expose to create a tweaked or a hacked version of semantic versioning that Windows installer would support, that could support. Namely, if you change the third dot, if you treat that as a dash, then you could technically treat everything after that as semantic versioning. I think we found the Windows installer behaved correctly there. But really, the only use of that would be for minor upgrades, and minor upgrades are so rare that it's hard to justify doing any real major work there. So really, semantic versioning on Windows installers not working in major upgrades, because the Windows installer doesn't look at the third part, which is why we could shove a string in there to begin with, really just turned into a string, a cosmetic kind of thing, and it's just a cosmetic thing plus a deviation from the semantic versioning spec. So all of that kind of went, probably not worth it. But supporting all this through everywhere and having Burn be able to support to absorb all these numbers is a good thing. So now that we have that nice little recap, hopefully that brought everybody up to speed. Now need to think about the dependency custom action. The dependency, not just custom action, the dependency code is used in Burn, and it has version numbers to say, this dependency is dependent on that other at this version, and then there's mathematics that can go there, newer, older, all that kind of good stuff. And it's used a lot inside Burn to do reference tracking. And there are custom actions that the Windows that you can add to your Windows installer to enforce several behaviors, dependency behaviors inside your MSI to operate correctly as well. And it uses version numbers, as I mentioned. And we need to go look at that usage, because I think that's the last place where we have version numbers that we need to go work. Because if Burn is going to start seeing version numbers or start writing version numbers of itself dependent on other things and writing its version, then it could add Wix version supported numbers, things beyond the number syntax, the 4-dot syntax. So we probably should update the dependency custom action to be able to support that semantics as well. And the nice thing is that, the 4 version, with Wix versions understanding 4.4, I don't know why I keep saying 4.4, the 4-part version, then it's at least backwards compatible. The tricky part is it's not exactly forwards compatible. So if you have old code looking at a dependency and it found a semantic version in there, old dependency custom actions would not be able to understand it. And I don't know how to think about that problem at the moment. So let's look at the code. All right, so the code is in the dependency utility code all the way over in, and it's provided in dutil, so anything can pull it up. It was actually in its separate library for a while, but maintaining a single library for essentially 2 TPP files, we decided it was core enough, we'd bring it down in dutil, then Burn and anything else that need to use it, like the custom actions, could just use it straight out of dutil. So that's why it now lives in dutil. And when you ask for the version name ID, the versions are strings here, which is good. So when you check a dependencies, the API is dealing with strings dealing as versions as strings, which is good, because that's what I think Burn is going to pass them down in. Well, obviously it must, because Burn is compiling against this code now. So if we go look at the code, so you pass in a min version and a max version, and optional, right? So we are checking a dependency, right? So you have this, you pass in the string, so you read what's available, and the dependency code uses the registry as its database of sorts. All of it's looked up in the database. So it'll go digging into the database, and then it will call regread version. And that will attempt to read the version in the registry as a 64-bit version. As a DWORD 64. And if we look at regread version, it's used in related bundles as well, which makes sense. Sorry, I'm jumping ahead. That's bundle code. Let's stick with the dependency code. Here it is in regutil. Yeah. It tries to query it as a, oh, interesting. All right, so here's regread version. So this is dutil code that helps us read registry keys. It calls in and tries to read as a 64-bit version. If it's not found, we're done. If it read the registry key as a string, then we read the string, and then we convert the string into a 4-part version. 4-part versions, if you consider each one being max being 65535, then you can fit it into a DWORD, 4 words into a 64-bit, and it all works out. If keyword, interesting, so we only read from strings right now. We don't read from the keyword type. All right, so this is good, I guess. It says that we're still storing versions as strings, or expecting them to be stored, or at least read them as strings. Suppose I should look for write version. Reg write version. No, there is none. Okay. So reg keyword, I don't know why we chose not to add that support. It's not, I guess it's not very common, but anyway. So we do require the file version from string.ex, and if we look at this is in file util. This does exactly what you would think it does. Yeah, chops off the version and then it lives for the 4 parts. Yeah. Loop, find the end, dots, uint16. Add it on to the part that we've got, and then we have our 4-part version. Which makes sense. That's how we get a 4-part version out of the registry. So but it's reading it as a D word. Oh, it starts the type. The type starts as 0. Oh, D word 64. Wait, what is type of 0 to reg query value? I haven't looked at this in so long. Let's go look real quick. Reg query value. The type of 0. Oh, it receives the type. Okay, so it's reading the type, and then it's reading the number of bytes that it can. So it's just asking for it as a D-word version. Right, so it's just asking for the value. So if the type comes back as, what other registry value types are there? Keyword, D-word 64. So if it comes back valid, that's not found. If the type is a string, read it as a string and convert it into that. Otherwise, oh no, if it is a keyword, oh duh, all right, read. So if it is a keyword, it is supported. If it reads it as a keyword, then only error if this returned an error. Got it. Yeah, okay, I totally read that wrong. That's right. So if it comes back as a keyword, then we're done. All we have to do is check the error code. If it comes back as a string, then we have to do extra work to read it, to turn it into a file string. Right. So if it reads it, so if it finds a keyword, it gets that, and anything else is an unexpected data type. There we go. Okay, that makes more sense. So if it's stored as a keyword, then it comes back as a 64-bit version. Got it. All right. Now this returns 64. Right. So if the dependency util is going, and it depends on read version. Okay. So that's how we get the version that exists already, and it puts them into dword 64s. And the nice thing about dword 64s is that by putting your 4-part version into a dword 64, then the math is easy. You just go compare them. If this one's bigger, smaller, equals, it's all just normal math. So if a version was provided, so that if they provided this version up here, interesting, I don't know why we don't do both of those in one check, but okay. Then we do a file version from string. Yeah, so we try to get the file version from that. Is this the same function that this is using? File version from string, good, yeah. So it tries to turn its version into a 64-bit version. And then it does the appropriate comparisons, tracking inclusiveness. So if we want to, yeah, this greater than or equals, okay. File version from string, file version from string ex, yep. So if we want dependency util to be able to read, to support more than dword 64 4-part versions, we need to change this code around a little bit. Where does it write the dependency? Let's see if we can find that code in here real quick. Let's check. Register a dependency with that version. It writes it as a string. All right, well that's good. So the dependency custom action already is storing them as a string. Yes, okay, so that's positive. So we don't have to change any of the public-facing dependency util API to support to support a Wix version instead of a 4-part version. Going back to where we were now, it's just a matter of changing this code to read the existing value as a string and turn it into a new version, a Wix version, and then do the comparisons based off of that, which is all doable. So we're already able to write strings that aren't 4-part versions. That's interesting. Just kind of thinking through the implications of this. We're essentially making dependency util more flexible because you could already have written a write dependency register with, let's say, a semantic version, and that could have been written here before. All right, cool. So let's say if you wrote a semantic version in the dependency, then it would come in here and then it would read, so it would open the existing thing, and then it would read version, which would come over here into read version. This would read it out. We would get a string, and then we would read, then we would try to convert it into a 4-part version. What would this do? The part's less than 4. All right, if the part is greater than 4. Okay, so what are we doing here? Part end, WZ part, and that does not equal a dot, so that's the end. Trying to do math here. Read those parts, get the next part, jump over the separator, and then to the next part. So if the separator is a dash, then the end would be before the dash. We convert it. We're not past the end of string. We come back, and then whatever was after the dash, we read the remainder, presumably. The begin equals the end. Okay, so if we didn't find anything else, okay, then we would get that, and then we would try to convert it to a uint 16. If we open stir util here, then this would call that. I just want to see the code that parses string length, read digits. If the digit is greater than, or not, let's see, if its digit is less than 0 or greater than 9, then it's not a digit. So we get an E invalid arg. So no luck there. If you put a semantic version in with the dependency code in the past, it would fail with invalid arg. It would not be not found, so it would hit here, it would say it failed to read the value for that dependency. It's interesting. So we can make this part read more flexible in the read. But if we write and then say an old bundle comes along and tries to read the dependencies of things with these versions, it's not going to work. That's tricky. So the new bundle would write its new version as the dependency string. The old bundle would then run and do a check, and the check would fail with invalid arg in the end, saying that the value is wrong. The version is wrong in the end. Where is this used? Let's see if we can see. Whoa. Oh. Okay. Guess I don't know which part Burn's using. Is it using the enum one? I thought it would just check. Dependent exists. Okay. Does Burn call this? Okay, there's the register. Let's go look inside the Burn code now. So here we go. We register a dependency, and yeah, this is what I expected. It's going to write the bundle version, which could now be a semantic version. It can be a Wix version, anything like that. All right, great. So dep. Too many deps. It's looking for everything as a dep. Dependency, I don't need any of the parsing code. Uninitialized detect provider, get provider information. Bundle key. So we don't look for the version there. Interesting. There's check dependence. Okay, what is check dependent? Did I not do check? All right, check dependence. Just wondering if, okay, kind of surprised that there's no versioning. Detect package dependence dependency. Yeah, okay. Detect package dependence. Is that here? Yep. Check dependence. All right, let's see. Check dependence. Oh, dependency. I see we have a whole struct here. And that has, no, just the key in the name. Okay. Dependency name. Kind of wondering, when do we check the version? Oh, we enumerate the keys. Interesting. Was this actually handed out by the... no. Okay. Oh, I'm in deputal. Duh. It's like, I want to get back over to Burn. There we go. Okay, back into Burn. Compare strings. I honestly thought I was going to find the version semantics faster. Ignore dependencies. I mean, it's... I believe that dep. Oh wait, might need to make opt in to use the semantic version to reinforce it using existing provider key could cause backwards compatibility issues. Look at before. Yeah. Look at burn v3. So that means burn doesn't care about the version as much. It registers its version. It gets its version here. Gets a compatible version. Okay. That's registering a dependency. Okay, wait. Let's go back. Where was this compatibility entry? What? And that's a version. Interesting. So burn only cares about it. It's the only thing that checks version. So that could say that the custom action is the only thing that cares about version. That definitely reduces our space. So this is where it's checking the versions. All right. Wait, where is version using? Get the string. Oh, there it is, check dependency. That's the one. And that's the one that passes string ins. All right, great. So here in this custom action, we can specify our min version and max version, which makes sense inside the MSI custom action. To then, what is it? Is this one block the install or, yeah, ensure required dependencies. Check the dependencies are installed for any provider component. Yep. And then you skip it if you disable the, all right. So then it prompts the user if they want to check. Otherwise, it will return the failure. So if we fail to parse any dependency, then this custom action will fail. All right, and what is the options for the user? Right. So the user can say, yes, I want to remove this anyway, even though something's dependent on it. And in this case, so if you had an old MSI with an old version in it that had this check, and something added a newer type of version on top on your MSI, say a bundle, then this code is the code that will fail. And the dependency check will always fail trying to run this test, right? Run this check right here. Dependency, check dependency. So just stepping back a sec, I wonder, this feels very familiar with issue we had in, I think it was Burn, where Burn was failing its entire operation when it couldn't process when the MSI data was out of whack for whatever reason. I think registry cleaners were one of the things that could delete part of the MSI database, but not all of it. So we could end up doing things like, hey, is there an MSI within this range? And we'd get back, yes, it's in this range, but then we'd find out that the rest of the data was missing or something to that effect. Essentially, it came down to when you're trying to read the existing data and the user's machine is corrupt from the point of view of this data for whatever reason, then what should you do? In this case, this custom action has decided to fail. it's going to fail on this provider, or no, on the ID of the row. Okay, so it's going to tell you, hey, the data on the user's machine is messed up, so I failed this dependency check. And that failure then is going to cause this installation to fail. Which is the straightforward answer. This returned failure, therefore don't continue. Alternatively, if you found that the data is corrupt, you can ignore it so that it does not, so that corrupt data does not prevent you from moving forward. Is that the right thing to do? What does that mean? That means you have a dependency, and for whatever reason, you can detect it, you can see it. So let's say you had a dependency where the version number got deleted, so it's no longer a valid version. The version registry key was, well, there, but it got corrupted with like gobbledygook letters. Then this code would always fail on this dependency check, and you'd never be able to progress. So I wonder, is it better for it to say, I can't parse that dependency is corrupted, therefore let me continue, and ignoring that dependency. Essentially, if it comes back invalid, if the dependency check, dep check dependency comes back invalid, the data found is invalid, then skip it. I wonder if that's the right thing for it to have done. Because otherwise you get trapped. You get an MSI that will not allow you to uninstall it. Well, no, you don't get trapped. You get trapped until you pass in the disable dependency check. So you have to skip this to get past. But if the data is busted, should you have to do that? It's an interesting philosophical question. Bob or Sean, you guys are here. Do you remember? I don't remember which of you guys made. I thought we changed this in Burn, where somewhere if we implement that, would block install, not uninstall. I don't think. For any components being installed or reinstalled. I thought there was one based off uninstall. I am conflating these. There's the require. Ensure required dependencies. Ensure required dependencies. Yeah, it's the same. I think it's for both cases. This is still going forward, are installed. I thought there was one on uninstall, but maybe not. Are install for any provided component that's being installed or reinstalled. Yeah, for being uninstalled. Right, so this one maybe doesn't care. Check dependence. This is the one that it doesn't care about the version. Right. If I found that, otherwise check that. Yeah, this is the same, it's kind of the same question. Where's check dependent? Oh, I'm debutal, not Burns dependency. Yeah, so try to open the key. If that fails, the dependency information is corrupt. So what should we do? Should we stop or should we continue? Could have sworn we changed this in Burn not too long ago. Well, a while ago. It was more than a little bit ago. It's the same thing here. If we can't read the dependence, do we prevent it or do we continue? Any votes from chat? Bob, Sean, Zach? Any opinions? I could go both ways. It's like, oh, well, if it's corrupt, then you're not going to be able to... You might be making the wrong decision. At the same time, if it's corrupt and you're trying to move forward, just wonder, should dependencies, if failure to read the dependencies, if that should be, is that fatal? If we couldn't check the dependencies, is that fatal? I don't know. Yeah, like if the enum fails for what, I don't know why reg enum, key enum would fail. So yeah, Sean and Bob in chat have both pointed out the two options, right? If that requires is to block the install if the dependency is missing. So if it can't check, then it should block. And Bob's case is it shouldn't be fatal because that's what happens. Then people go off and trying to hack the registry, MSI Zap or whatever to force the machine into their will when dependencies are busted. So a middle ground would be let the user choose, which is rarely a good choice because you have to say, hey user, we could not find this software. Do you want to continue? Or sorry, we failed while trying to check if this dependency was present. Do you want to continue anyway? You're like, I don't know. That's not a great option either. We were searching for this provider key and could not tell at the time. So it doesn't... I didn't expect to hit a philosophical question when looking at the dependency custom actions here, or the dependency code in general. So if it finds the provider and that key is corrupted, then it's blocking right now. Min version, max version. Right. The simple answer is to do it burned in. Parse it as a Wix semantic version and rely on its comparison logic. The simple answer is do it burned in parses. Well, yeah, the question that solves the version number issue, but like if the registry key is corrupted for whatever reason, or we can't open it at this time, then we're blocked. Should we be blocked on this? Because Wix 3 custom actions, I mean, I'm not sure anybody uses this. Like, how do you use this anyway? The Wix dependency custom action code. let's back up and look at that. This is why is being blocked bad? Why is being blocked bad? Because you're blocked for something that you can't fix. Like you're blocked by something that isn't necessarily related exactly to the software you're looking at. For whatever reason, the registry in this area is corrupt. Should you be prevented from continuing? That's really what it comes down to. So this is requires. Yeah, there's very little to it. You just require your ID. Mm-hmm. And it uses the data from that. Things that not many people use the requires inside the MSI. Yeah, ignore dependencies is the way out. I mean, there's that escape hatch. Is there one for the uninstall one too? I didn't, let's look at that real quick. That was down from here. Ensure required dependencies. Nope, the other one, the uninstall one. Ensure absent, not. Wix dependency check, yeah. Determine in the right context. Ensure absent dependence. Ensure absent dependence table. There it is. Ignore dependencies. So that, I guess, is your way out of this. Is if you get stuck, you somehow run this MSI with ignore dependencies, or the other option is to install with the disable dependency check. Yep. Disable dependency check is for requires and ignore dependencies is for the provides. Well, and the so what does that mean? So then ensure absent dependence. Whoop, too far. And then when this fails, you will get the ID of the dependency in your MSI. So you can tell the user, oh, for whatever reason, your machine, this dependency could not be verified. We looked in our MSI that we built, we find the provider key, and we add that to the ignore dependencies, and then you can manually uninstall this thing, and you're okay again. So that's how you can at least get the thing bypassed. Is that you have the escape hatches of the ignore dependencies. And that probably is static. Oh, okay, this is the trophy. Skipped if upgrading code is set. That's interesting. Is that? Skipped if upgrading product code is set. Does it? I didn't see it do that anywhere. Ignore dependencies. Oh, are you going to read a function? Ah, okay. Or you're going to read the property? Okay. This is interesting. I wonder what that code means. I don't know if that's true. All right. All right, so you can specify ignore dependencies, including all, to get it off the machine, even if the dependency data is broken. if it came back invalid arg and we skipped it, this is checking all the dependents. So that would mean, well, okay, so these are failures right up. Then check key num. If the key isn't ignored, if it's not ignored, then get the name and add it to the array of things that were dependent. Got it. That makes sense. And then if there were dependents, there we go. Now we can spit out their names and everything. Okay. So in that case, if you failed, we would be, I was just thinking, if you had one dependent that was corrupted, incorrectly left behind, and messed up, partially removed. Yeah. Then I guess you just add it to the ignore. Okay. I guess that's the answer, is you just add it to the ignore and you get your way out because something happened to your registry. All right. So that does mean also that if we support these newer versions, the Wix 3 check dependents will start failing here. That's because the version numbers will look, well, it won't fail here because this check dependence doesn't look at the version number, right? Check dependence get name, right? Just gets the name. So this isn't the one. The only one that's gonna be a problem is the require. So if we ensure that we have a required dependency, and we want to check that dependency exists and is within the range of this code. And if this is before we fixed it, did I copy it? Then we'd find the existing one. Its version would not be a 64-bit version. We would come back saying it's invalid, and that would block you from installing because you would see that there's something on the machine, but it is invalid. It's there, but invalid. And we wouldn't even get an error message. The MSI would just fail. Okay. Now, how does this happen? This happens because, how does this happen? You are looking at a provider key that got registered by something else that you want to use, and you wanted it between these versions, potentially between these versions. Unfortunately, I think, yeah, we read the version no matter what, even if you don't say that you want to do the checks. That's too bad too. That would have narrowed it down. Struggle, trying to get a needle our way through here. Yeah, so even if we don't have a min version or a max version, we still read the version right there. So we always read the registry, so it's always going to fail, even if you're not checking the versions. Okay, so if you have a dependency on the product code, on the provider key, so if you specified a dependent on something else and then that installed with a newer version of All right, so that says that if it's within your control and you're supporting old products, don't use newer versions, because they won't work with the V3 products. Until you get everything upgraded to V4, you can't use newer versions in V4. Okay, that's better. It means you just can't use this feature until you get there, until you get your old code all updated to this. And when are people doing this? So it's one of the things it can, it's blocking the install. I want this software installed. And if it's installed with a newer version of people using old code, it would be if you're looking for a bundle. So you have an MSI that's saying it requires a bundle. That bundle is built by Wix 4, has a semantic version, registers a semantic version. The old V3 based MSIs that want to say, I want to make sure that that MSI is still installed, will fail. Given the popularity of the requires element, or the lack of popularity, that's probably all right. Because I don't know many people that publish their provider keys today. I know Visual Studio used it a lot internally. Now, this makes me more confident about being able to add this feature. And if you have a provider key that needs to be used with older software, then you just can't, you should not use this feature because the older software will be broken. It will not be able to read that version. That works. That actually works. That actually works. It's kind of like, yeah, this message here, getting this error, breaking change about the different way of version numbers. All right, I think that's the way to go. Okay, so what did we do here? We are going, I consider writing breaking change note. And let me write this and then see if that makes sense. Breaking note, change note that if a provider key uses a Wix version that a non-4-part version, Wix version, aka semantic version, that that old V3 based requires custom actions will fail because they are unable to parse the version number. In this case, continue to use a 4-part version until all V3 code is upgraded to V4. All right. Now the nice thing about this is now if we go forward, we put this node in, people continue to have to ship their versions. They basically can't take advantage of the new versioning until the V3 code for the requires custom action. They can't take advantage of newer version numbers for the requires custom action until all their V3 code is upgraded. But going forward, using verutil in here instead of the more strict versioning comparison that we're doing now means that we will means that we're more flexible. Like Sean was saying, we will handle arbitrary versions better as we go forward, because the verutil attempts to make the best guess at what it can do with the versioning. So that puts us in a good spot going forward. All right, so after all of that hemming and hawing over what exactly is broken in the old, if we support this, I think we're actually in a good spot. And I think adding this will put us in a better spot going forward post v4, should we extend this, at least the code will try and it should not give up as rapidly. All right, that's good. So a little bit of implementation details then in the last few minutes here. We have reg read version. We need something, or we'll want something like that. No, let's open the reg. Yes, control open reg util. Oh, my bad. Inc reg util.h version, reg read version. So the question is, do we have a reg read version ex? I'm inclined to say we add a reg read wix version for util version and for util.h. What is it called? Versions? Oh, just pointers? Fine. P version as a Wix version. Is that the way to do it? I mean, I'm just thinking names. Alternatively, we could call it version EX, but I don't know that's EX. It's kind of like, let's read it in a different format. What do you guys think? What do you guys think in chat? Like, is it this? Something like this? I think I like that better than reg read version EX. I think reg read version EX is not quite right because we're changing the output format. Any takers? Any opinions? Let's see. How much of this is not duplicated? Let's just say I'm going with that for now. Given not much feedback. Okay. Okay, now this is the tricky part. Really, we just want to read a string, right? We're just going to read a string. Yeah, we're just going to read a string. Although we could read it out of number types as well. We probably should read it. Okay, fine. We'll read it as both. So fine. Okay, let's support both for the backwards compatibility. Yeah, exactly. Vireo supports converting the keywords to string. That's exactly it. We'll do both. This one. D word 64. And, all right. So now we have the version. If it is a string, read it as a string. And for usual, for not compare, I need to parse. Version for keyword. Great. That's what I want. And this goes into, there is a free version. Okie dokie. What are we calling verutil things that are not pointers? No results? They're all pointers? Really? I guess. Oh, because they're all allocated. Okay, fine. Oh. All right. All right. Right, parse version. What are we doing? Parse version. Yes, okay. And what is your problem? Oh, because all the other things are wrong. Okay, fine. Okay, let's see. Where are we at? 12 seconds it says. All right, let's just kind of line this up. Now I don't like this. I think that goes there. Yeah, I have to get that all formatted right. And parver util. Where's Q version? There, from keyword. From keyword. All right, let's see. So that, something like that, and then don't know if I actually need to do this release semantics or not. Do I have a release? Is there a release macro? There is. All right, something like that. And can I pass 0 as the size and it will calculate for me? Yes, all right, great. Strict, I think the answer is false. For strict, that will get us past the that. All right, I don't know if that's correct, but it's a bunch of code slammed out really fast. Put us in a spot to pick up there later. Are there double spaces or single double spaces? All right, so that puts it in a good spot to figure out the ending for next time. Ending, I say that. We will pick up there in the Wix custom action code, dependency custom action code, to continue teaching how to handle Wix versions so it becomes a little more forgiving about the types of versions and a little bit more forgiving about the comparisons of strings. So until then, all of you keep coding. You know I am. Ta-ta.